Hello, now we are going to look at the cosine rule. So this is the cosine rule here. We have a squared is equal to b squared plus c squared minus 2bc cos of a. So first of all, let's read where all of these letters are coming from, and then we'll have a quick discussion as to where we might get this formula from. So we have a relationship for a non-right angle triangle. So this works for right angle triangles and non-right angle triangles, but we usually use it for non-right angle triangles. So we have the side A is the one off being squared by itself, and then the angle that's referred to in this formula is the one that is opposite that side. So angle A is the opposite to side A. Angle B is on the opposite side to side B, and so on. So what we've got is this side by itself to be squared is equal to these two sides squared and added together minus 2 times BC cos of the opposite angle. The only thing that is really important is this side is opposite to this angle. So little a is across from angle A. Now, where this formula comes from is we take what we know about right angle triangles and try to extend it into non-right angle triangles. So if I take my triangle here, I break it up into right angle triangles by getting the perpendicular height away from the side C. So angle C would be up in this corner here. I get the perpendicular height away from my side C, and that gives me two little right angle triangles. And what I do is relate the two little right angle triangles together using the perpendicular height here, because it gives me two right angle triangles with the same perpendicular height. And as you might expect from the fact that I have a squared is equal to b squared plus c squared as part of my cosine rule, I end up relating them using Pythagoras. So I end up using Pythagoras' theorem to relate the square of the perpendicular height to the sides here and the angles here as I've listed them. Now the algebra gets quite messy, and this is also not a formal proof, so I am skipping actually writing it out for you, but this is to give you a feel for why there is stuff that looks like Pythagoras involved in our final answer. So this is roughly where our formula is coming from, and again, the key thing to this formula, the thing that we can make a mistake with and we need to be very careful of, is we have our angle A, and the side opposite that is our side little a. And this works for any of the sides in our triangles. So we could have c squared is equal to a squared plus b squared minus 2ab cos of c. It can, any side and the opposite angle will work for the cosine rule, and it works for all types of triangles. Now, where we would particularly want to use this is if we know all three sides of the right angle triangle, all three sides of the triangle, and we want to find an angle in it. This is the only tool that is going to allow us to do that. So we'd see we have something we don't know to be a right angle triangle. We say I have all three sides and I want the angle. Which one of my formulas for a non-right angle triangle connects all three sides and an angle? And the only thing that does that is the cosine rule. All three sides are in the cosine rule, and I have an angle. So if I have three sides missing an angle, or if I put three sides and an angle, I am going to look for the cosine rule. So I'm going to sub into my formula here, and again, I have to be very careful. The angle I'm interested in is theta. Theta is just a Greek letter. It's an O with a squiggle in the middle of it. So if that's the angle I'm interested in, the A over here is going to be 36. It will be the side that is opposite to the angle. So this is going to be the angle capital A. This is going to be the side little a, because it's on the opposite side of the shape. So 36 squared, if I change my color, 36 squared is going to be equal to 25 squared plus 29 squared minus 2 times 25 on 29 cos of theta. Again, the circle with the squiggle in the middle. So that's the angle I'm looking for. When I do that, I see I now have an equation that just has theta in it, or cos of theta in it. So this is an equation I can solve in order to find theta. So I just need to be careful. I'm going to square all of these things individually and work carefully through my numbers because they get quite big and awkward. So I'm just going to start working down through. 36 squared is 1296, 625. I'm going to write this out and just tidy it up. Now I can rearrange my formula. I want to get the cos theta as much by itself as possible so that I can find out what theta is. I'm going to make both sides smaller by 1461, and I end up with minus 170. The minus 1450 cos of theta. Now I want to get cos of theta by itself, so I'm going to divide so that I end up with 1 of cos theta. So I have to divide by minus 1450. And I end up with 17 all over 145 is equal to cos of theta. And then I want to get theta by itself, so I'm going to have to take the inverse cosine, because inverse cosine of cosine is just the input to the function. That's how inverse functions work. They're the functions that undo the original function and to leave us with the input. So inverse cosine of 17 all over 145 is just a calculator job, and I end up with 83.2671 to 4 decimal places is equal to theta. Now we don't normally give an answer like that, so I'm going to round that to the nearest degree. So that to the nearest degree, that is going to be 83 degrees for theta. Now, if I have a triangle that I don't know to be right angled, and I know these two angles, I know this side, and I want to know the opposite side, this is another instance where the cosine rule is the tool that I would want. I can relate all 3 sides together along with an angle. So if I have that relationship, often the cosine rule is a good one to go with. But I would look at all of my tools and see which one gets me the side length that I need. So in this case, let's say I would have a squared is equal to b squared plus c squared minus 2bc times cos of a. So I have x would be my side, and then the opposite angle would be 30. So this would be angle A and side A. So I'd write down my cosine rule to keep track of what it is I need to do, because it's quite a long formula. It's important to have it written down for ourselves on the page, and then we can work down, we can sub in x squared is going to be 12 squared plus 18 squared. Does not matter what order these two are in, because they're just added or multiplied. Cos of 30. So then we start to tidy all of that up. So x squared is going to be 144 plus 324 minus, all of that can go into our calculator, and we get minus 374.1227. This is actually an approximation of a surd, so you can write this, you can keep this with the square root in it if you are comfortable with that. I've left it here as a decimal, just as an example of doing it as a decimal. I have gone to 5 decimal places here just because of the way the rounding worked, but going to 4 decimal places if you're going to decimals is a good rule of thumb for when you are working. Now when we work all of that down, as it turns out, 3, 8, 7, the next decimal I think was 0. So I now know that x squared is going to be equal to this stuff, so I am going to get the square root of both sides. Whenever I get a square root, I could theoretically have, or mathematically, I could have a negative or a positive answer. However, in this case, x is the physical length of the side of something, so I'm just going to be interested in I'm just going to be interested in the positive result. So technically minus 9.689 squared would also give me 93.877, but I'm not interested in that answer because of the context of the question. But I should always have plus or minus values in mind whenever I take a square root. Now again, how many decimal places will we go to? I'm going to say that I'm going to go to the nearest whole number. So in this case, the nearest whole number would be 10 units. So that is how we can use the cosine rule where we have non-right angle triangles, and it also works for right angle triangles. And that is what we need for now.